Welcome. Tonight is for quiet discovery as we explore the gentle reality of life beyond our world. Here, the science is soft, the facts are steady, and the atmosphere is entirely safe for your rest. You are invited to simply listen as we wander through the quiet mechanics of the cosmos. There is no rush to understand or remember. Everything is slow. The silent vacuum of space is not truly empty, but it is incredibly still, and within that stillness, the laws of physics behave in ways that feel like a dream. On the International Space Station, the sun rises and sets 16 times every single day, casting a rhythmic, golden light across the modules every 45 minutes. It is a peaceful thought to consider that as you settle into your blankets, there are people living in a state of constant, gentle float. They exist in a world where the concept of weight has dissolved, replaced by a soft, weightless drift that lasts for months at a time. In this environment, every movement is deliberate and slow. There is no pressure on the joints, no strain on the back, and no heavy pull of gravity against the skin. It is perhaps the most profound state of physical relaxation a human can experience. We will explore the subtle details of this life, how plants grow in the dark, how water forms perfect, shimmering spheres, and how the silence of the void creates a unique kind of peace. Everything here is factual, calm, and designed to carry you toward a deep, natural sleep. In the environment of Earth's orbit, the absence of gravity changes the very shape of the human body. Without the constant downward pull of the planet, the fluid in the body begins to drift upward, settling evenly and softening the features of the face. The spine, no longer compressed by the weight of the world, gently lengthens. Astronauts often find themselves becoming an inch or two taller during their stay in the stars. This expansion happens slowly and naturally, a quiet adjustment to a place where the heavy burdens of Earth no longer apply. It is a physical release, a literal loosening of the body's structure. The way one sleeps in space is a testament to this total lack of tension. There is no need for a mattress, as there is no floor to rest upon. Instead, residents of the space station sleep inside soft, padded bags attached to the walls. These bags are not meant to support weight, but simply to keep the sleeper from drifting into the delicate instruments of the cabin. When an astronaut sleeps, their arms naturally float upward and forward into what is known as the neutral body posture. It is the position the body assumes when every muscle is completely relaxed, a soft, curved stance that requires zero effort to maintain. They drift in a cocoon of silence, governed only by the gentle hum of the station's life support systems. Air in space must be carefully managed, and the fans provide a constant, low-frequency white noise that many find deeply soothing. This mechanical breath is the heartbeat of the station. It ensures that pockets of carbon dioxide do not form around the sleeper's head, as warm air does not rise in microgravity. Instead, the air is moved in a steady, predictable flow, creating a consistent environment that never fluctuates in temperature. It is a climate of perfect, unchanging mildness. When water is released into the cabin, it does not fall or splash. Because surface tension becomes the dominant force, water pulls itself together into a shimmering, translucent globe. These spheres of water hover in the air, wobbling slightly like gelatin when touched. If two spheres meet, they do not shatter, they simply merge into one larger, calm orb. Watching a sphere of water move through the air is a slow and hypnotic experience. It moves with a heavy, liquid grace, reflecting the soft lights of the laboratory in its curved surface. To wash one's face in space is to apply a thick, clinging layer of moisture that stays exactly where it is placed, wrapping the skin in a cool, gentle hydration that does not drip. The plants grown on the station also adapt to this quiet world. In the small growth chambers, seeds are nestled into pillows of clay and nutrients. Without the pull of gravity to tell the roots to go down and the shoots to go up, the plants rely entirely on light. They stretch toward the soft glow of LED lamps, growing in slow, deliberate patterns. Red and blue lights are often used, creating a serene, colorful garden in the corner of a metal room. These plants produce small amounts of oxygen and offer a touch of the living world to the inhabitants. The smell of damp earth and green leaves is a rare and precious thing in the sterile environment of space, providing a grounding, earthy scent that lingers quietly in the air. Outside the thick, pressurized windows, the view of the Earth is a constant source of calm. From 250 miles above, the planet looks like a fragile, glowing marble of deep blues and brilliant whites. There are no borders visible from this height, only the slow crawl of clouds over vast oceans. The atmosphere appears as a thin, delicate ribbon of neon blue hugging the curve of the Earth. It looks incredibly soft, like a veil of silk protecting everything beneath it. To watch the world from space is to see time pass in a way that feels irrelevant. Hurricanes look like still, white spirals, and the lights of cities at night twinkle like distant, earthbound stars. The silence of a spacewalk is perhaps the deepest silence a human can know. While the suit is filled with the sound of one's own breathing and the quiet whir of a cooling pump, the world outside the visor is utterly mute. There is no wind to carry sound, no air to vibrate. The stars do not twinkle in space, they shine with a steady, unblinking light because there is no atmosphere to distort them. They appear as perfect, crystalline points of light against a blackness so deep it feels velvety. Moving through this void requires slow, rhythmic motions. Every handhold is gripped with care, and every movement is calculated to be smooth. It is a slow-motion ballet performed in a theater of infinite shadow. Inside the station, the lighting is programmed to mimic the natural cycles of Earth. As the crew nears their rest period, the harsh blue lights of the daytime modules fade into warm, amber tones. This transition helps the brain prepare for sleep, signaling the end of a long day of science and maintenance. The transition is gradual, much like a sunset on the ground, casting long, soft shadows across the equipment. In these moments, the station feels like a quiet home, a small bubble of warmth and life protected by layers of aluminum and titanium. Even the food in space is designed for a gentle experience. Because crumbs could float away and interfere with hardware, many foods are prepared with thick sauces or stored in pouches that keep everything contained. Eating becomes a slow process of savoring textures. Salt and pepper are used in liquid form, as grains of spice would simply float into the air. This means every meal is seasoned with precision, the liquid drops merging into the food to create consistent, mild flavors. The act of eating in a floating state allows the body to focus entirely on the senses of taste and smell, which are often slightly muted in space, making every bite a mindful experience. The station itself is a marvel of steady engineering. It travels at 17,500 miles per hour, yet inside, there is no sensation of speed. There is no vibration, no wind, and no acceleration. It feels as still as a library. The walls are lined with soft fabric in some areas to dampen sound, and the various modules are connected by narrow, circular hatches that remind one of a cozy, subterranean burrow. Moving from one module to another is as simple as a light push with a single finger, gliding effortlessly through the air like a bird on a thermal. This ease of movement extends to the work the astronauts perform. When repairing a piece of equipment, tools are often held in place by strips of Velcro or magnets to prevent them from wandering. There is a specific, quiet order to everything. A misplaced wrench does not fall to the floor with a clatter, it simply stays where it was left, hovering patiently until it is needed again. This lack of clutter and noise creates an environment of extreme focus and tranquility. The mind is not distracted by the usual chaos of a terrestrial workshop. Communication with the ground is also a rhythmic, steady process. Voices from mission control come through the headsets with a slight electronic hum, providing a tether to the world below. These conversations are brief, professional, and calm. They are the only reminders of the billions of people living their lives beneath the clouds. For the crew, the isolation is not a source of stress, but a form of sanctuary. They are the only humans in the vastness of the local cosmos, a small family bound by the shared experience of living among the stars. The chemistry of the human body adjusts to this isolation in fascinating ways. The immune system becomes slightly more relaxed, and the circadian rhythms are carefully maintained by strict schedules. Even the way a candle would burn in space is different. On Earth, a flame is teardrop-shaped because hot air rises. In space, a flame forms a perfect, glowing blue sphere. It burns slowly and dimly, consuming oxygen at a measured pace. While open flames are not allowed on the station for safety, the science of how they behave illustrates the theme of space. Everything tends toward the shape of a sphere, everything moves toward a state of equilibrium. As the station passes over the night side of the Earth, the crew can sometimes see the aurora borealis or australis from above. These curtains of green and purple light dance over the poles, undulating slowly like silk in a breeze. From orbit, you can see the depth of these lights, watching them tower up into the thin upper reaches of the atmosphere. They do not flash or flicker, they glow with a steady, ethereal radiance that can last for hours. It is one of the most serene sights in the universe, a silent light show powered by the interaction of the sun's wind and the planet's magnetic shield. Life in space is a life of constant, gentle observation. One becomes acutely aware of the smallest details, the texture of a glove, the taste of recycled water, the specific hum of a laptop fan. Because the environment is so controlled, the senses become finely tuned. There is a profound sense of presence that comes from living in a place where every breath is provided by a machine and every view is a masterpiece of cosmic history. It is a slow existence, defined by the steady tick of the mission clock and the endless, circular journey around the blue world below. In the quiet of the station, the concept of a day is redefined by the passage of time across different time zones below. To maintain a sense of normalcy, the station operates on Coordinated Universal Time, or UTC. This provides a steady, unchanging temporal anchor for the crew. While the world below cycles through morning rushes and evening sunsets, the astronauts follow a clock that remains indifferent to the rapid orbital transitions outside. This structure creates a predictable internal rhythm, allowing the mind to rest in the certainty of a well-defined schedule. Every hour is accounted for with a gentle precision, ensuring that the transition from work to rest is seamless and expected. The materials used within the living quarters are chosen for their neutrality and safety. Surfaces are often smooth, matte metals or high-grade polymers that feel cool to the touch. There are no sharp edges, every corner is rounded, designed to be kind to a body that might accidentally drift into it. This softness of design contributes to the overall feeling of being in a protective cocoon. The interior lighting is diffuse, intentionally avoiding harsh glares or deep shadows, which helps to maintain a visual environment that is easy on the eyes. As one moves through the modules, the transition from one section to another is marked only by a slight change in the pitch of the background machinery, a soft auditory cue that one is entering a different part of the home. Maintaining physical health in orbit is a slow and deliberate process. Because there is no gravity to resist, muscles and bones do not have to work to support the body. To keep the body strong, astronauts use specialized machines that simulate weight through resistance. Using these machines is a rhythmic activity. One might spend an hour moving against the steady pull of vacuum cylinders or elastic bungees. The movements are repetitive and slow, creating a meditative state of exertion. There is no heavy clanking of iron plates, only the rhythmic hiss of the pistons and the steady sound of one's own breath. This daily ritual is a quiet affirmation of the body's connection to Earth, a way of remembering the feeling of weight while existing in a state of weightlessness. The sense of smell in space is unique and often described as metallic or sweet. When a hatch is opened after a docking procedure, the scent of the vacuum, clinging to the outer hulls of visiting craft, wafts into the station. It is a faint aroma, reminiscent of seared steak, hot metal, or the ozone smell after a lightning storm. This scent is not overpowering, it is a subtle, atmospheric reminder of the vast, cold void just inches away on the other side of the hull. Inside the station, the air is scrubbed and filtered so thoroughly that it becomes almost odorless, a blank canvas that allows the faint scent of the cosmos to become a gentle curiosity. In the microgravity environment, the way one experiences their own body changes. On Earth, we are always aware of the pressure of our feet on the ground or our seat in a chair. In space, that pressure disappears. The skin, no longer subject to the constant friction of clothing pulled down by gravity, feels a new kind of freedom. Clothing is typically loose and made of soft cotton, designed to float slightly away from the skin. This lack of tactile resistance creates a sensation of physical expansion. The body feels as though it has no boundaries, merging quietly with the air around it. It is a state of total physical liberation, where the very idea of a heavier limb becomes a distant memory. The science of fluid dynamics in space is a source of endless, quiet wonder. Without gravity to cause convection, heat travels through liquids and gases differently. In a cup of warm tea, which must be sipped from a sealed pouch, the heat stays concentrated, moving slowly through the liquid in a steady, predictable manner. There is no swirling of steam rising upward. This means that a warm drink stays warm for a very long time, providing a consistent source of comfort. The steam, if allowed to escape, would simply hover in a small, misty cloud near the opening, moving only when caught by the gentle currents of the ventilation system. Observations of the Earth's surface from the cupola, the large, multi-windowed observation module, offer a perspective of profound stillness. From this vantage point, the geological features of the planet appear as giant, frozen works of art. The Sahara Desert reveals intricate patterns of orange and gold dunes that look like ripples in silk. The Amazon River appears as a silver thread winding through a carpet of deep, mossy green. Mountain ranges like the Himalayas look like jagged white teeth, their peaks dusted with permanent snow, appearing completely stationary despite the incredible speed of the station. Watching these features slide by is like looking at a high-definition map that slowly breathes. The stars, when viewed from the shadow of the Earth, are more numerous than any human on the ground could ever imagine. Without the interference of the atmosphere, which scatters light and causes stars to twinkle, each point of light is a solid, unmoving spark. The Milky Way appears not as a faint smudge, but as a thick, brilliant river of stardust stretching across the entire sky. It has a depth and a texture that is almost tactile. One can see the dark lanes of cosmic dust blocking the light of more distant stars, creating a complex tapestry of light and shadow. This view is a silent reminder of the scale of the universe, a scale so large that individual worries feel as small as a single atom. Even the way the station handles its waste is a quiet, efficient cycle. Water is a precious resource, and every drop is captured, filtered, and reused. This includes the moisture from the breath of the crew and the sweat from their skin. The recycling systems are masterpieces of chemistry, turning yesterday's waste into tomorrow's pure, clean drinking water. This closed-loop system creates a sense of harmony with the environment. It is a reminder that in space, nothing is wasted, and everything has a purpose. The quiet hum of the water recovery system is the sound of sustainability, a steady process of purification that never stops. The exterior of the station is covered in layers of high-tech blankets called multilayer insulation. These blankets are often gold or silver in color and are designed to reflect the intense heat of the sun and retain warmth during the darkness of orbital night. They are soft to the touch but incredibly strong. These layers act as a thermal shield, keeping the internal temperature of the modules at a constant, comfortable level, regardless of whether the outside skin is being baked at 250 degrees Fahrenheit or frozen at -250 degrees. This thermal stability is crucial for the comfort of the crew, ensuring that they never feel the harsh extremes of the cosmic environment. Communication with loved ones on Earth is done through private video calls and emails. These moments are quiet highlights of the day. Seeing a familiar face or hearing a voice from home provides a soft emotional anchor. The delay in the signal is minimal, allowing for natural, slow conversations. These interactions are a reminder that while the astronauts are physically far away, they are still deeply connected to the human story unfolding below. They share stories of their floating life, describing the view of a sunset over the Pacific or the way a piece of fruit behaves when released in the cabin, turning a scientific mission into a shared human experience. The station's laboratory modules are filled with experiments that run quietly in the background. Many of these involve crystals, which grow much larger and more perfectly in space than they do on Earth. Without gravity to disturb their structure, the atoms arrange themselves in flawless, repeating patterns. These crystals grow slowly, molecule by molecule, creating beautiful, transparent geometries. Watching the progress of such an experiment over weeks is a lesson in patience and the quiet power of natural laws. The lab is a place of silent growth, where the secrets of materials are revealed in the absence of weight. At night, or during the designated sleep period, the station enters a low activities mode. The lights are dimmed, and the non-essential systems are quieted. The crew retreats to their small, private sleep stations, which are about the size of a telephone booth. Inside, they can customize their environment with photos from home, a small laptop, and their sleeping bag. It is a very personal, very quiet space. As they zip themselves into their bags, they might listen to recordings of rain on a tin roof or the sound of wind in the trees, sounds of Earth that contrast with the mechanical hum of their current home. This ritual of transition helps to bridge the gap between the high-tech reality of space and the biological need for a natural, peaceful rest. The structural integrity of the station is monitored by thousands of sensors. These sensors listen for the faint pings of micrometeoroids or the subtle stresses of thermal expansion. Most of the time, the station is silent, a testament to its robust construction. The modules are bolted together with massive collars and seals that have held firm for decades. This reliability provides a deep sense of security. To live on the station is to trust in the quiet strength of engineering, knowing that you are encased in a vessel designed to withstand the most challenging environment known to humanity. In the absence of a traditional down, the brain eventually adapts, creating its own sense of orientation. An astronaut might decide that the wall they are facing is the floor, and their brain will quickly accept this new reality. This mental flexibility is a quiet form of human evolution. It allows the crew to move through their three-dimensional world with a grace that seems impossible on the ground. They can work at any angle, standing on the ceiling to reach a cable or floating sideways to look through a window. This freedom of orientation makes the station feel much larger than it actually is, as every surface is a potential workspace or resting spot. The passage of time on the station is marked by the completion of mission phases and the arrival of resupply ships. These ships arrive like quiet messengers, bringing fresh food, new experiments, and letters from home. The docking process is a slow, careful dance of two spacecraft moving at thousands of miles per hour but appearing to nudge each other with the gentleness of a feather. The mechanical clunk of the docking latches is a satisfying sound, signaling the arrival of new resources and the continuation of the mission's steady progress. As you listen to these details, you might imagine yourself drifting alongside the station, weightless and free. The blackness of space is not a cold or frightening place in this context, it is a vast, quiet field of potential. It is a place where the laws of nature are laid bare, and where the human spirit finds peace in the simple act of existing among the stars. The station continues its journey, a silent, glowing dot in the night sky, carrying its inhabitants through a world of soft science and endless, relaxing discovery. The rhythm of life in orbit is further defined by the movement of the station's massive solar arrays. These wings of golden black silicon stretch out into the void, silently rotating to track the sun's path. They move with a precision that is invisible to the naked eye, a slow and constant adjustment that ensures the station remains powered by the steady flow of photons. When the station passes into the Earth's shadow, the arrays are feathered to reduce drag against the incredibly thin remnants of the upper atmosphere. This transition happens in a moment of profound beauty called orbital sunset. The white light of the sun turns to a deep orange, then a thin sliver of violet, and finally, the station is plunged into a 45-minute night. This cycle is the pulse of the station's electronic life, a quiet heartbeat of energy and darkness that repeats thousands of times a year. Inside the quiet modules, the air is kept at a constant humidity, ensuring that the mucous membranes of the nose and throat do not become dry. This subtle environmental control is essential for the comfort of the crew. In this perfectly balanced atmosphere, the breath comes easily and slowly. There is no pollen, no dust, and no pollutants. The air is perhaps the cleanest air a human can ever breathe, having been purified by layers of molecular sieves and charcoal canisters. This purity adds to the sense of being in a sanctuary, a place where the biological needs of the human body are met with silent, mechanical grace. The soundscape of the station is a layer of white noise that many astronauts describe as a comforting presence. Beyond the fans, there are the quiet whirs of the centrifuges and the intermittent click of solenoids. These sounds are not jarring, they are the ambient background of a living machine. They indicate that all systems are functioning within their normal parameters. Over time, the crew becomes so accustomed to these sounds that they no longer hear them consciously, but their presence provides a subconscious reassurance that the environment is stable. If a fan were to stop, the sudden silence would be the most noticeable sound of all, but as long as the low hum persists, the mind is free to drift into a state of calm. The physics of a simple object, like a floating pen, reveals the gentle nature of the environment. If you were to place a pen in the center of a module and let it go, it would stay there, hovering in the air. It might slowly begin to drift toward a ventilation intake, pulled by the very slight current of the air, but the movement would be so slow it would take minutes to cross the room. There is a peacefulness in watching an object remain suspended in space, untethered by gravity. It challenges the lifelong intuition of the mind, replacing the expectation of a fall with the reality of a drift. This visual stillness is a powerful tool for relaxation, encouraging the viewer to let go of their own internal tensions. The windows of the station are several layers thick, made of high-quality quartz and borosilicate glass. Between the panes, there is a vacuum, providing a perfect thermal and acoustic barrier. When you press your forehead against the cool glass of the cupola, you are looking through a portal that has remained unchanged for years. The scratches on the outer pane, caused by the impacts of microscopic dust particles, are the only signs of age. These tiny pits are like scars of travel, reminders of the station's long journey through the cosmic landscape. Looking through them, the universe looks clear and infinite, a silent expanse that invites the mind to wander without limit. The clothing worn by the crew is replaced rather than washed, as liquid water is too precious for laundry. This means every few days, an astronaut opens a vacuum-sealed bag of fresh, clean cotton clothes. The smell of new fabric is a small but significant comfort. These clothes are simple: t-shirts, cargo pants with plenty of Velcro, and soft socks. Without the need for shoes, the feet become quite sensitive. The skin on the tops of the feet often becomes thickened because astronauts use them to hook under handrails to stay stable while working. This is a quiet adaptation of the body, a physical record of life in a world without flaws. Scientific research on the station often focuses on the behavior of fire in a way that is incredibly serene. In specialized, sealed chambers, researchers ignite small droplets of fuel to study cool flames. These are flames that burn at temperatures so low they are almost invisible to the human eye. They exist in a state of chemical balance that is impossible to achieve on Earth. These spheres of combustion represent the ultimate efficiency of energy, burning slowly and steadily until the fuel is exhausted. The study of these flames helps scientists understand how to create cleaner engines on Earth, but in the quiet of the lab, they are simply beautiful examples of the universe's hidden symmetries. When it comes to rest, the absence of a pillow in the traditional sense is compensated for by the total relaxation of the neck muscles. On Earth, the head always wants to fall to one side, requiring support. In space, the head simply remains in line with the spine. Some astronauts use a small strap to keep their head from bobbing, while others enjoy the sensation of their head floating freely. This lack of pressure on the skull can lead to a very deep and restorative sleep, free from the tossing and turning associated with finding a comfortable position on a mattress. The body remains perfectly still for hours, suspended in a dark, quiet alcove of the station. The water on the station is often described as having a very neutral, clean taste. Because it is recycled through such high-grade filtration systems, it lacks the minerals or chlorine smells often found in municipal tap water. Drinking this water is a pure experience of hydration. It is often consumed through a straw from a silver pouch, a slow and deliberate act. The coolness of the liquid as it enters the body is a grounding sensation, a reminder of the fundamental elements that sustain life, even in the most technologically advanced environment ever built. As the station orbits, it occasionally passes through the South Atlantic anomaly, a region where the Earth's inner Van Allen radiation belt comes closest to the planet's surface. During these passes, astronauts sometimes report seeing light flashes even when their eyes are closed. These are caused by cosmic rays interacting with the optic nerve. They appear as tiny, silent streaks of white light, like miniature shooting stars inside the mind. These flashes are a gentle reminder of the invisible energies that permeate the cosmos, a silent light show that occurs in the quietest moments of the night. The maintenance of the station is a task of quiet repetition. Replacing a charcoal filter, checking a valve, or wiping down a handrail are all performed with a slow, methodical pace. There is no reward for rushing in space. In fact, moving too quickly can lead to mistakes or unwanted momentum. By working slowly, the crew maintains a state of constant mindfulness. Every turn of a screw is felt, every movement of a cable is watched. This slow-motion productivity creates a calm atmosphere where work and meditation become one and the same. The exterior of the International Space Station is not just metal, it is also covered in blankets of white fabric called beta cloth. This material is made of fine glass fibers woven together and coated with Teflon. It is designed to be fire-resistant and to withstand the harsh UV radiation of the sun. This fabric gives the station a soft, quilted appearance in certain areas, contrasting with the hard edges of the solar panels and radiators. This soft exterior is another layer of protection, a textile shield that keeps the inhabitants safe from the vacuum. The station is a fortress of cloth, metal, and glass, drifting silently through the void. The transition from the orbital night back into the light is a gradual awakening. First, a thin line of electric blue appears on the horizon of the Earth. It glows with an intensity that seems to vibrate. Then, the colors shift into a pale gold, and finally, the sun bursts over the curve of the planet, flooding the modules with a clean, white light. This sunrise happens every 90 minutes, but it never loses its quiet impact. For the crew, it is a signal to begin the next cycle of science and discovery, a rhythmic return to the light that defines their lives in the stars. Communication with the ground often involves the use of quiescent periods where the station is out of range of tracking satellites. During these times, the station is truly isolated. There are no voices from the ground, no data transfers, just the crew and the machine. These periods of silence are highly valued, offering a chance for deep reflection and quiet companionship. It is a time to look out the window and watch the Earth pass by in total stillness, a reminder of the vast distances that separate the station from the rest of humanity. As the mission nears its end, the astronauts begin to prepare for their return to the heavy world below. They spend more time on the exercise machines, preparing their muscles for the return of gravity. They look at the Earth with a sense of quiet anticipation, knowing that soon they will feel the wind on their faces and the smell of rain on the grass. But they also feel a sense of peace with the space they are leaving behind. They have lived in a world of soft science and floating dreams, a place where the heavy burdens of Earth were momentarily lifted. The memory of life in space stays with them as a feeling of lightness and quiet. They remember the way the water looked, the way the stars didn't twinkle, and the way it felt to sleep without a flaw. These memories are like a quiet reservoir of calm that they can draw upon for the rest of their lives. And as you listen to these words, you can draw upon that same calm, imagining yourself in that quiet, floating world, where everything is slow, everything is safe, and everything is at peace. The interior architecture of the station is a study in functional minimalism that fosters a quiet mind. Every surface is utilized, yet there is a profound sense of openness because the concept of a floor is absent. Equipment is tucked into standardized racks that line the walls, ceilings, and floors of the modules. These racks are uniform in their appearance, finished in soft grays and off-whites that do not demand the eye's attention. Moving through the connecting nodes, the air feels slightly different, perhaps a degree cooler or a fraction more humid, providing a subtle sensory map of the station. This consistency of design ensures that no matter where an astronaut is, they feel a sense of belonging and familiarity. The physics of gravity-free combustion remains one of the most hypnotic areas of study in this high-altitude laboratory. When a small flame is ignited in a controlled chamber, it behaves with a quiet purity that defies terrestrial logic. On Earth, a flame is shaped by the rising of hot air, creating a flickering, pointed tip. In the stillness of orbit, where there is no up, the flame expands into a perfect, translucent blue sphere. It does not flicker. It does not smoke. It simply glows with a steady, haunting light, consuming oxygen in a perfectly even radius. To watch such a flame is to see the very essence of chemical reaction, stripped of the chaos of gravity. It is a slow, silent burn that represents the ultimate state of thermal equilibrium. This same sense of equilibrium extends to the way fluids move through the station's plumbing. The life support systems manage miles of tubing that transport water, oxygen, and coolant. Because there is no gravity to help move these fluids, the station relies on small, silent pumps and the natural behavior of surface tension. In these pipes, air bubbles do not rise to the top, they remain suspended within the liquid. Specialized separators use centrifugal force to gently spin the fluids, drawing the heavier liquids to the outside and allowing the air to be drawn from the center. It is a graceful, mechanical process that happens entirely out of sight, maintaining the station's vital signs with the quiet efficiency of a biological circulatory system. The sensation of time is further softened by the absence of the typical sounds of human industry. There are no distant sirens, no hum of traffic, and no barking dogs. The only sounds are the ones created within the station itself. Even the crew's movements are nearly silent, because they do not walk, there is no sound of footsteps. They move by swimming through the air, using light touches on handrails to guide their path. A person can travel the entire length of the station without making a single sound, gliding through the modules like a ghost. This acoustic velvet creates a space where one can truly hear their own thoughts, fostering a deep sense of internal peace and presence. In the galley, the preparation of tea or coffee is a ritual of patience. The water is heated in a small machine and then injected into a vacuum-sealed pouch containing the beverage powder. As the water enters the pouch, it doesn't splash, it slowly inflates the bag, swirling the powder into a rich, dark liquid. The astronaut then massages the pouch gently to ensure the mixture is consistent. Sips are taken through a straw equipped with a small clamp to prevent the liquid from escaping. This slow, tactile process turns a simple drink into an act of mindfulness. The warmth of the pouch against the hands is a comforting, grounding heat that radiates through the fingers in the cool air of the cabin. The station's exterior sensors are constantly recording the faint sounds of the magnetosphere. While space is a vacuum and cannot carry sound waves as we know them, the interaction of solar winds with the Earth's magnetic field creates electromagnetic frequencies. When converted into audible sound, these chorus and hiss emissions sound like distant birdsong or the gentle lapping of waves on a shore. For the researchers listening to these recordings, the universe sounds like a vast, living ocean. These radio waves are the invisible music of the spheres, a constant, ambient melody that plays out across the solar system, entirely indifferent to the frantic pace of life on the ground. The materials science experiments on board often involve the creation of metallic foams. On Earth, creating a foam out of liquid metal is difficult because the bubbles of gas rise and pop before the metal can solidify. In the weightless environment of the station, the bubbles stay perfectly distributed throughout the liquid. As the metal cools, it forms a structure that is incredibly light yet remarkably strong, similar to the internal structure of a bone. The process is slow and silent, taking place inside a vacuum furnace. The resulting materials are masterpieces of structural efficiency, grown in a place where the rules of weight have been suspended. The windows of the station are protected by external shutters when not in use. Opening these shutters is a deliberate, mechanical process. As they swing away, the light of the Earth or the stars floods into the room, changing the color of the walls and the mood of the space. The sunlight in space is unfiltered and pure, lacking the yellow tint provided by Earth's atmosphere. It is a brilliant, diamond-white light that reveals the true colors of every object it touches. When this light hits a floating crystal or a drop of water, it refracts into 1,000 tiny rainbows that dance across the instrument panels. It is a silent light show that celebrates the simple beauty of optics. The crew's health is monitored by small, wearable sensors that track heart rate and sleep patterns. In the quiet of the night, these devices record the deepest states of rest imaginable. Without the pressure of a mattress against the skin, the heart does not have to work as hard to circulate blood to the limbs. The pulse slows to a rhythmic, steady beat that mimics the low hum of the station's fans. It is a state of physiological tranquility that is difficult to achieve on Earth, where the body is always fighting the subtle, constant stress of its own weight. In orbit, the body is finally at rest, suspended in a state of total, weightless surrender. Even the way the station maintains its orbit is a slow and calculated affair. Occasionally, the station will fire its thrusters or use the engines of a docked cargo ship to boost its altitude. This is not a sudden jolt, it is a gentle, sustained push that lasts for several minutes. The crew might feel a very slight sensation of weight, a phantom pull toward the back of the station, but it is so faint it is almost indistinguishable from a breeze. This correction ensures the station stays above the thickest parts of the atmosphere, preserving its home in the stars for years to come. It is a quiet nudge in the right direction, a reminder that even in the vastness of space, we can maintain a steady and predictable path. As you drift further into this description, the details of the station begin to blur into a single, cohesive feeling of safety. The modules are warm, the air is clean, and the view is infinite. You are in a place where the laws of physics are your protectors, and the silence is your companion. The Earth continues to turn below, a beautiful, blue marble that provides the backdrop for your journey. There is no need to hurry, no need to worry, and nothing to do but exist in this state of perfect, floating calm. The station is your sanctuary, a bubble of life and light in the soft, dark velvet of the cosmos. The architecture of the International Space Station is further enhanced by the presence of small, stowable handrails that line every corridor. These rails are powder-coated in a soft, neutral blue, providing a gentle grip for the hands or feet. Moving through the station is less about strength and more about a rhythmic, tactile connection with these rails. An astronaut can travel with the grace of a swimmer, using only the tips of their fingers to initiate a glide. This constant, light contact with the station's structure creates a sense of physical intimacy with the machine. You are not just inside the station, you are part of its movement, a slow-moving element in a perfectly balanced system of physics and engineering. In the quiet hours of the night shift, the station's illumination is reduced to a soft, green glow from the status indicators on the various racks. This dim, ambient light is reminiscent of a quiet forest at dusk. In this low light, the various modules seem to expand, their boundaries softening into the shadows. The absence of sharp shadows and bright glares allows the eyes to relax completely. The visual field becomes a landscape of soft gradients, where the hard edges of technology are smoothed away by the dimness. It is a time for introspection, for looking out through the small portholes at the stars, which appear even brighter against the darkened interior of the station. The scientific study of colloids in space offers another glimpse into the serene physics of microgravity. Colloids are mixtures where tiny particles are suspended in a liquid, like milk or paint. On Earth, gravity causes these particles to eventually settle at the bottom, but in space, they stay suspended indefinitely. Scientists observe these mixtures as they slowly organize themselves into complex, crystal-like structures. This process happens over days and weeks, a silent dance of molecules that move with a deliberate, invisible purpose. Watching a colloidal experiment is like watching the slow growth of a coral reef in a deep, still ocean. It is a testament to the order that emerges when the chaotic pull of gravity is removed. The station's cooling system is a masterwork of silent thermal management. Because there is no air outside to carry heat away, the station uses large, white radiators that extend into space like the feathers of a bird. Inside, a closed-loop system of water and ammonia circulates through the walls, absorbing the heat generated by electronics and human bodies. This liquid moves through the station with a steady, pulsing flow, carrying the warmth toward the external radiators where it is radiated away into the cold void as infrared light. This process is entirely silent, a constant, invisible respiration that keeps the interior at a perfect 72 degrees Fahrenheit. It is a reminder that the station is a living organism, constantly regulating its internal state to ensure the comfort of its inhabitants. The sensation of up and down is replaced by a sense of relative orientation. In the Japanese experiment module, known as Kibo, the interior is spacious and brightly lit, with a clear sense of floors established by the placement of equipment. However, an astronaut might choose to work while floating upside down relative to that floor. To the brain, the floor simply becomes whatever surface the feet are closest to. This neurological shift happens gradually over the first few days in orbit, eventually becoming a natural and effortless way of perceiving the world. It is a quiet liberation of the mind, a breaking of the terrestrial chains that dictate how we perceive our place in space. In the cupola, the 7 windows offer a panoramic view of the Earth that is often experienced in total silence. Some astronauts spend their free time here just watching the clouds. At this height, the clouds appear to have a soft, 3D texture, casting long, elegant shadows over the ocean during the golden hour of orbital sunrise or sunset. The transition of the clouds from bright white to deep orange and then to a ghostly blue in the moonlight is a slow-motion spectacle of light and water. There is no sound of wind or rain from this height. There is only the visual beauty of the weather, a silent movie of the planet's atmospheric life played out on a global stage. The preparation of clothing for a spacewalk is a methodical, multi-hour process that highlights the theme of protection and safety. The Extravehicular Mobility Unit, or EMU, is essentially a small, person-shaped spacecraft. Putting it on involves a series of slow, checked steps, ensuring every seal is tight and every connection is secure. Once inside the suit, the astronaut is enveloped in a private, pressurized world. The sound of their own breathing becomes the dominant rhythm, a steady, life-affirming sound that contrasts with the silence of the vacuum outside. The suit is heavy on Earth but weightless in space, providing a soft, padded environment that moves with the body's every gesture. The behavior of air bubbles in a floating liquid is a source of quiet fascination. If an air bubble is introduced into a sphere of water, it does not rise to the surface. Instead, it hovers in the center, or moves slowly toward the edge if the sphere is spun. If multiple bubbles are present, they can be seen to slowly merge, or coalesce, into a single, larger bubble. This process is driven by the subtle forces of surface tension, a slow-motion attraction that happens without a sound. Watching the bubbles move within the transparent liquid is a hypnotic experience, a study in the hidden forces that shape our world but are usually drowned out by the noise of gravity. The station's library of digital media includes thousands of hours of ambient sounds and music, which the crew often plays in the background of the laboratory modules. The choice of music is usually calm, ambient electronic, soft classical, or acoustic instruments. These sounds blend with the mechanical hum of the station, creating a rich, lead acoustic environment that supports a focused yet relaxed state of mind. The music doesn't compete with the station, it complements it, adding a human touch to the metallic world of the modules. It is a subtle way of maintaining a connection to the culture and beauty of the world below. Every piece of equipment on the station is designed for longevity and ease of repair. The philosophy of maintainability means that everything can be taken apart and put back together with a few simple tools. This creates a sense of empowerment and security. If a fan makes a new sound, it is not a cause for alarm, it is simply a task to be performed with the same slow, methodical care as everything else. The astronauts become intimately familiar with the insides of their home, knowing the path of every wire and the function of every valve. This deep understanding fosters a sense of being at home in the machine, a quiet confidence that the environment is stable and well cared for. As the station passes over the dark side of the Earth, the cities below appear as golden webs of light. The intensity of the light varies, dense clusters of brilliance in the great metropolitan areas, fading into thin threads of light along highways and coastlines. These lights represent millions of people, yet from this distance, they are silent and still. The view is a reminder of the interconnectedness of humanity, a glowing tapestry of civilization seen from a place of ultimate perspective. It is a peaceful sight, a golden glow against the dark velvet of the planet's surface, suggesting a world at rest. The biological clocks of the crew are reinforced by the use of circadian lighting. The LED panels in the modules change their color temperature throughout the day, shifting from a bright, invigorating white in the morning to a warm, sunset amber in the evening. This subtle change in the light spectrum tells the body when to be alert and when to begin the process of winding down. It is a technological mimicry of the Earth's natural cycles, ensuring that even in a place where the sun rises 16 times a day, the human body remains in harmony with its ancient biological rhythms. The shift in light is so gradual that it is barely perceptible, a silent cue for the brain to transition into a state of rest. The memory of a spacewalk is often defined by the sensation of the sun's heat on the suit. When in direct sunlight, the exterior of the suit can reach temperatures of 250 degrees Fahrenheit. The astronaut can feel this warmth as a gentle radiance, filtered through the many layers of the suit's insulation. It is a pure, cosmic heat, a direct connection to the energy of our star. When the station moves into the Earth's shadow, this warmth is replaced by a deep, penetrating cold, though the suit's internal heaters quickly compensate. This rhythmic oscillation between the heat of the sun and the cold of the shadow is the heartbeat of the spacewalker's experience, a silent pulse of energy and ice. Inside the quiet modules, the smell of fresh coffee or a warm meal can travel quite far, as there is no convection to keep the scent localized. A person at one end of the station might catch the faint, pleasant aroma of a colleague's dinner from 3 modules away. These olfactory clues are small, human moments in the high-tech environment. They provide a sense of community and shared life, a reminder that the station is a home as much as it is a laboratory. The scents are never sharp, they are always soft and diffused, carried by the gentle breath of the ventilation fans. As you continue to listen, the details of the station's life settle into a steady, unchanging background. The hum of the fans, the glow of the lights, the weightless drift of the water, all of it becomes a single, cohesive experience of peace. You are floating in a world of soft science, where every fact is a comfort and every observation is a step toward deeper relaxation. The station continues its endless circle around the world, a silent guardian of human knowledge and a sanctuary for those who travel among the stars. Everything is safe, everything is slow, and everything is at rest. The internal environment of the station is a masterpiece of acoustic engineering, designed to prevent the build-up of echoing sounds that might disrupt the calm of the crew. Many of the walls are lined with specialized acoustic blankets made of a soft, fire-resistant Nomex material. These blankets absorb the stray sounds of conversation, the humming of computers, and the clicking of switches, creating a dead acoustic space that feels very much like a quiet, high-end recording studio. In this environment, a whisper can be heard clearly from several feet away, yet it doesn't carry or reverberate. This sonic softness allows the mind to stay in a state of tranquil focus, undisturbed by the sharp or sudden noises that are so common in life on Earth. The physics of sleep in this quietude is particularly fascinating. Because there is no gravity to pull the tongue or the soft tissues of the throat downward, snoring is significantly reduced in space. Most astronauts find that their breathing becomes remarkably clear and effortless as they drift in their sleeping bags. The air they breathe is constantly monitored for oxygen and carbon dioxide levels, ensuring that the atmosphere remains fresh and life-sustaining throughout the night. As the sleeper floats, their body naturally settles into the fetal position, not because of emotional comfort, but because that is the state of total muscular neutrality. It is the body's most natural form, achieved only when the weight of the world is truly lifted. Outside the station, the radiators that dissipate heat into the void are coated in a specialized white paint containing zinc oxide. This paint is designed to be highly reflective of solar radiation while being an excellent emitter of infrared energy. Watching these radiators from a window is a lesson in stillness. They do not move, they do not vibrate, and they do not make a sound. Yet, they are working constantly to maintain the delicate thermal balance of the modules. They are silent sentinels of the station's life support, turning the invisible energy of heat into light and sending it out into the infinite darkness of the universe. The sensation of time on the station is further modulated by the Daily Planning Summary, or DPS. This is a digital timeline that every crew member follows, displayed on laptops throughout the modules. The DPS is a colorful, horizontal scroll that shows every task, from scientific experiments to exercise and meal times. There is something deeply soothing about the steady movement of the current timed line across this plan. It provides a visual representation of progress and order. Even when the work is complex, the plan itself is a source of calm, ensuring that no one is ever rushed and that every task has its own dedicated space in the quiet flow of the day. The behavior of light as it passes through the atmosphere of the Earth is a constant subject of observation for those in orbit. During the moments of nautical twilight seen from above, the atmosphere acts as a prism, separating the sun's white light into a vibrant spectrum. You can see a layer of deep navy blue, followed by a bright cyan, a thin line of green, and finally a soft, glowing orange. These layers are perfectly horizontal, hugging the curve of the planet like the rings of a tree. They look incredibly fragile, a thin veil of gas that is the only thing standing between the life on Earth and the harsh vacuum of space. Observing this beauty is a silent, daily ritual that reinforces a sense of stewardship and peace. The station's internal plumbing for oxygen generation is a quiet, electrochemical process. Through a system called the Oxygen Generation System, or OGS, water is split into its base components of hydrogen and oxygen using electricity. The oxygen is then vented into the cabin air, while the hydrogen is often combined with waste carbon dioxide to create more water. This cycle is a silent, molecular dance that happens inside a series of metal canisters. There are no loud chemical reactions, just the steady, rhythmic movement of molecules being rearranged to support life. It is a reminder that even the most basic human needs are met with a sense of quiet, technological harmony. When an astronaut moves through the station, they often use a technique called fingertip walking. By placing just the pads of their fingers against the walls or equipment, they can navigate with extreme precision. This requires very little physical effort and creates a heightened sense of touch. One becomes aware of the different textures of the station, the cold smoothness of the aluminum, the slightly rough weave of the Velcro strips, the soft give of the acoustic blankets. This tactile variety provides a subtle, sensory richness to an environment that might otherwise feel overly mechanical. It is a slow, tactile exploration of a home that is unlike any other. The science of capillary flow is another area where the station's quiet physics is put to use. On Earth, we use pumps to move liquids, but in space, liquids can be moved through very narrow channels using only their own surface tension. This is the same force that allows a paper towel to soak up water. On the station, specialized capillary cups allow astronauts to drink from an open container for the first time. The shape of the cup uses the liquid's own properties to climb up the side and stay at the rim, allowing for a normal sipping motion. It is a beautiful example of how humans can adapt to the laws of the universe by working with them, rather than against them, creating a more natural and relaxing experience. The station's communication arrays are constantly tracking the TDRS satellites that orbit much higher than the station. These satellites act as relay stations, bouncing data and voices back and forth between the station and the ground. The movement of the station's antennas is slow and deliberate, a silent tracking of invisible signals across the void. Even when the station is on the opposite side of the planet from mission control, the connection remains steady, a digital thread that keeps the crew from feeling truly isolated. This constant, quiet connectivity provides a layer of psychological safety, a reminder that help and companionship are always just a radio wave away. In the laboratory, that microgravity science glove box provides a sealed environment for experiments that might be messy or involve small particles. Inside this glass-walled box, researchers can manipulate objects using built-in gloves. The interior of the glove box is illuminated by soft, flicker-free lights, creating a miniature world of focused research. Watching a scientist work in the glove box is like watching a jeweler or a watchmaker. The movements are incredibly precise and slow. There is a profound silence within the lab during these moments, as the entire focus of the mission narrows down to the movement of a single crystal or a drop of liquid. The exterior of the station is also home to various external payloads that study everything from cosmic rays to the health of the Earth's forests. These instruments sit quietly on the outside of the modules, staring out into the void or down at the planet. They record data for years at a time, their electronic eyes never blinking. They are the silent observers of the universe, gathering knowledge that will eventually be sent back to Earth for scientists to study. The station is not just a home for humans, but a massive, multifunctional sensor that breathes in the data of the cosmos, contributing to the steady, quiet expansion of human understanding. As the station moves into the dark portion of its orbit, the interior lights are often dimmed to a very low level, allowing the crew to better see the stars and the lights of the Earth. During these times, the modules take on a different character. The familiar equipment becomes a landscape of shadows and soft glows. It is a time for quiet conversation or solitary reflection. The station feels like a small campfire in the middle of a vast, dark wilderness. The warmth and light inside are a precious contrast to the cold infinity outside, a cozy pocket of life that is both isolated and perfectly secure. The memory of the station's smell often lingers with astronauts long after they return to Earth. It is a clean, slightly metallic scent, often compared to the smell of an ozone generator or the air after a summer rain. This scent is a product of the high-tech materials and the advanced air filtration systems. It is not a scent that demands attention, it is simply a part of the atmosphere, a quiet, olfactory background to the mission. It becomes associated with the feeling of safety and the routine of daily life, a sensory anchor that signifies home in the high-altitude world of the station. As you listen to these details, you may find that your own breathing has become slower and more rhythmic, matching the steady pace of life in orbit. The station continues its graceful, silent journey, and you are right there with it, drifting through a world of soft science and weightless peace. The universe is vast, but you are in a place of perfect safety, surrounded by the quiet hum of human ingenuity and the steady laws of nature. Everything is calm, everything is slow, and you are ready for a deep and restorative rest. The steady circulation of the air within the station is a constant, gentle process that ensures every module remains fresh and breathable. Because there is no natural convection in weightlessness, the air does not move on its own, it must be pushed by a series of quiet, high-efficiency fans. This creates a soft, consistent breeze that can be felt if one remains perfectly still. It is a cooling, refreshing sensation, like the faint draft of a window left open on a mild spring day. This movement of air is essential, not just for temperature control, but to prevent the buildup of gases in the quiet corners of the laboratory. It is a silent, mechanical respiration that mirrors the steady breathing of the crew as they work and rest. In the European Space Agency's Columbus module, the lighting is designed to be particularly soft and diffuse. The panels are integrated into the ceiling and floor, casting an even glow that eliminates harsh shadows. This module is often used for biological research, and the environment is one of clinical cleanliness and profound quiet. Scientists here might study how the cells of a leaf react to the lack of gravity, or how small aquatic organisms navigate in a world without an up or down. These experiments are performed with a slow, methodical grace, every movement recorded by high-definition cameras that see every minute detail. The lab is a sanctuary of observation, where the smallest ripples of life are studied in the most peaceful environment imaginable. The exterior of the station's Russian segment features a distinct design, with many modules covered in a heavy, durable thermal padding that looks like a dark gray quilt. This material is designed to absorb the impacts of tiny dust particles while providing a robust layer of insulation against the extreme temperature swings of orbit. Walking, or rather, crawling, along the outside of these modules during a maintenance task is a slow and tactile experience. The fabric has a slight give to it, a soft texture that contrasts with the cold, hard metal of the handrails. It is a reminder that even in the vacuum of space, there is a need for softness and protection, a literal cushioning against the harshness of the void. The science of crystal growth in the station's furnaces is a process that defines the word slow. In the absence of gravity, crystals of protein or semiconductor material can be grown without the distortions caused by their own weight. These crystals form atom by atom over several weeks, creating structures of such purity and symmetry that they look like jewels. They grow in total darkness and total silence, shielded from the vibrations of the rest of the station by specialized vibration isolation platforms. These platforms use magnetic levitation to keep the experiment hovering, completely disconnected from the walls of the module. It is the ultimate expression of stillness, a miniature world where time seems to stand still so that perfection can emerge. The way water behaves on the exterior of a spacesuit during a leak test is a beautiful display of fluid physics. If a tiny amount of moisture escapes, it does not run or drip. Instead, it forms a perfect, shimmering bead that clings to the fabric of the suit through molecular attraction. This bead might wobble slightly as the astronaut moves, but it remains a cohesive, translucent sphere. In the direct light of the sun, these droplets sparkle like diamonds against the white beta cloth of the suit. They are small, silent reminders of the strange and beautiful ways that common substances behave when the rules of the Earth no longer apply. Inside the station, the use of acoustic standoffs helps to keep the noise levels low. These are small, rubberized mounts that sit between the loud machinery, like pumps and compressors, and the metal frame of the station. They act as shock absorbers, soaking up the vibrations before they can turn the walls into giant speakers. This engineering detail is what allows the station to remain a place of calm. It is a conscious choice to prioritize the psychological well-being of the crew, ensuring that their home remains a quiet refuge rather than a noisy factory. The result is a sonic environment that is as steady and predictable as the orbital path itself. The storage of food on the station is an exercise in organization and quiet preparation. Meals are kept in large, fabric-lined containers called bricks, which are velcroed to the walls of the galley. Each packet is color-coded by crew member and mission day. Choosing a meal is a slow process of browsing through the pouches, dried fruits, thermally stabilized meats, and vacuum-sealed vegetables. There is no clatter of plates or silverware. Everything is handled with soft, plastic utensils and flexible pouches. This lack of percussive noise makes mealtime a peaceful, social experience, where the focus is on the taste of the food and the quiet companionship of the team. The station's global transmission services antenna sends out a timed signal that can be picked up by radio-controlled watches on the Earth below. This antenna sits on the outside of the Zvezda module, a silent broadcaster of precision. As the station orbits, it tells the world what time it is, providing a constant, rhythmic pulse of data that synchronizes clocks across continents. It is a subtle way the station serves the planet, a quiet voice in the electromagnetic spectrum that helps keep the human world in sync. Inside the station, the crew follows this same time with a sense of shared purpose, their lives governed by the steady, unblinking digits of the mission clock. When an astronaut looks through the earth-facing windows at night, they might see the faint, ghostly glow of their glow. This is a phenomenon where the atmosphere itself emits a soft, green or reddish light due to chemical reactions triggered by sunlight during the day. It looks like a thin, luminous halo hugging the dark limb of the planet. It is much fainter than the aurora, requiring the eyes to adjust to the darkness for several minutes before it becomes visible. This breathing of the atmosphere is a silent, nightly occurrence, a gentle reminder that the planet is a living, chemical system that never truly sleeps. The maintenance of the station's carbon dioxide removal system is a vital, quiet task. This system uses a material called zeolite, which acts like a molecular sponge to soak up the CO2 from the air. Periodically, the system breathes by venting the trapped gas out into space and regenerating the zeolite for another cycle. This process happens with a soft, rhythmic hiss that can sometimes be heard near the life support racks. It is the sound of the station cleaning itself, a mechanical exhale that ensures the air remains crisp and clear. This constant renewal of the atmosphere is what allows the crew to remain healthy and focused throughout their long stay in the stars. The sensation of floating while performing a task is often described as a form of effortless focus. On Earth, we spend a significant portion of our mental energy just maintaining our balance and posture. In space, that energy is freed up. When a scientist is looking through a microscope or a technician is wiring a circuit, they can do so while suspended in mid-air, their body completely relaxed. This leads to a state of flow, where the task and the person become one. The absence of physical strain allows the mind to enter a deeper level of concentration, a quiet, meditative state of productivity that is unique to the orbital environment. The windows of the Zvezda module are among the oldest on the station, and they have a slightly different character than the newer ones in the cupola. They are smaller and have a faint, golden tint due to the coatings used to protect them from radiation. Looking through these windows is like looking through a vintage lens. The Earth appears with a soft, nostalgic glow, the colors slightly more muted and warm. It is a peaceful view, a reminder of the decades of human presence in this high-altitude home. These windows have seen hundreds of sunrises and sunsets, yet they remain clear and steadfast, providing a quiet portal to the world below. As you listen to these steady facts, the station continues its journey, passing over oceans and continents in total silence. You are part of this journey, a passenger in a world of weightless calm and soft, scientific discovery. The air is fresh, the lights are low, and the environment is perfectly secure. There is no need to think about the world below, for now, your world is this quiet, floating sanctuary. The stars are bright and unblinking, the Earth is a glowing blue marble, and you are drifting into a state of deep, natural peace. Everything is slow, everything is safe, and you are ready for a long and restorative sleep. The structural integrity of the station is quietly maintained by a series of internal pressure sensors that monitor the atmosphere with extreme precision. These sensors are so sensitive that they can detect the minute change in air pressure that occurs when an astronaut moves quickly from one module to another. Because of this, the crew moves with a deliberate, slow-motion grace, ensuring that the environment remains as stable as possible. This slow movement becomes a way of life, a physical philosophy that emphasizes the importance of patience and care. In the quiet corridors, there is no sound of rushing or urgency. Everything happens in its own time, governed by the steady laws of orbital mechanics and the soft requirements of the human body. The behavior of magnetic fields in the station's laboratory provides another layer of silent, scientific wonder. In experiments involving ferrofluids, liquids that become strongly magnetized in the presence of a magnetic field, the absence of gravity allows the fluid to form intricate, spiking geometries that would be impossible on Earth. These fluids move with a smooth, oily grace, responding to the invisible pull of magnets with a silent, dancing motion. They form shapes that look like alien flowers or crystalline structures, shifting and flowing without a sound. Watching these fluids is a hypnotic experience, a visual representation of the invisible forces that permeate the universe, operating with a quiet and unwavering logic. The station's external robotic arm, known as Canadarm2, is a masterpiece of slow-motion engineering. This massive, white arm can move thousands of pounds of equipment with the precision of a surgeon's needle. When it moves, it does so at a pace that is almost imperceptible to the eye, traveling only a few centimeters per second. This ensures that every movement is safe and controlled. From the windows, the arm looks like a long, elegant limb reaching out into the blackness, illuminated by the bright, white light of the sun. It operates in total silence, a mechanical extension of human intent that bridges the gap between the pressurized modules and the infinite vacuum outside. Inside the quiet modules, the crew often uses small, handheld vacuums to clean the air filters. This is a rhythmic, satisfying task that is part of the station's weekly routine. The sound of the vacuum is a soft, domestic hum that contrasts with the high-tech environment. As the filters are cleaned, the air quality remains at its peak, ensuring that every breath taken by the crew is clean and invigorating. This simple act of maintenance is a grounding ritual, a reminder that even in the most advanced laboratory ever built, the basic needs of a clean and healthy home are universal. It is a quiet moment of order in the complex life of the mission. The chemistry of the station's water recovery system involves a process called catalytic oxidation. This process breaks down organic impurities in the water at a molecular level, using heat and specialized catalysts. It is a silent, internal fire that purifies the water without the need for harsh chemicals. The result is water that is chemically pure and perfectly safe for drinking, cooking, and hygiene. This system is a closed loop of sustainability, a mechanical version of the Earth's natural water cycle. The quiet efficiency of this process is a testament to human ingenuity, allowing a small group of people to live for years in a place where there are no natural springs or rain clouds. The sensation of thermal comfort on the station is maintained by a complex network of heat exchangers. These devices transfer heat between the internal air and the external cooling loops. Because there is no up or down for the air to move, the station uses diffusers to spread the air evenly throughout the modules. These diffusers are designed to prevent the formation of drafts, ensuring that the temperature remains perfectly consistent from the floor to the ceiling. This creates a thermal environment that is neither too warm nor too cool, a state of perfect, unchanging mildness that allows the body to relax completely. It is like being wrapped in a thin, invisible blanket of perfect air. In the quietest parts of the station, such as the back of the Zvezda module, the walls are often covered in soft, fabric pockets that hold personal items. These pockets are a soft, tactile detail in a world of metal and glass. Running a hand over them reveals the different textures of the mission, the smooth nylon of the pockets, the rough grip of the Velcro, and the soft cotton of the items inside. These small, human touches make the station feel less like a machine and more like a home. They are the silent repositories of a life lived in the stars, a collection of small comforts that provide a sense of continuity and peace. The way the station's solar arrays glow during an orbital sunrise is a sight of profound beauty. Before the sun itself is visible, the arrays catch the first rays of light, turning a deep, glowing amber. This light reflects off the golden-brown surfaces of the silicon cells, casting a warm, metallic light onto the nearby modules. It is a soft, silent awakening of the station's power system, a visual signal that a new day has begun in the 90-minute cycle of the orbit. Watching this light spread across the station is a calming experience, a rhythmic return to the energy and light that sustains all life in the solar system. The science of microencapsulation on the station involves the creation of tiny, liquid-filled shells that can be used for medicine. In space, these shells form into perfect spheres because there is no gravity to squash them. These spheres are incredibly uniform in size and shape, making them more effective than those made on Earth. The process of creating them is a slow, liquid dance performed inside a specialized laboratory rack. The result is a collection of tiny, shimmering pearls of science, each one a perfect example of how the unique environment of space can be used to improve life on the ground. It is a quiet, microscopic success story that unfolds in the stillness of the lab. The station's external cameras are often used to monitor the health of the solar arrays and the radiators. These cameras can pan and tilt with a slow, mechanical precision, providing a 360-degree view of the station's exterior. Looking through these cameras is like being a silent observer of a massive, drifting castle. You can see the different textures of the station, the smooth, white beta cloth, the shiny gold of the insulation, and the dark, patterned silicon of the solar cells. Everything looks pristine and still, a silent monument to human cooperation and scientific curiosity. The cameras record this beauty for the world below, providing a constant stream of tranquil images that invite the mind to rest. As you continue to listen to these steady, calming facts, you may find that the boundaries of your own room have begun to fade. You are drifting with the station, a weightless passenger in a world of soft science and quiet discovery. The universe is a place of order and beauty, and you are perfectly safe within its laws. The air is fresh, the hum of the fans is steady, and the view of the Earth is a constant source of peace. There is no need to hurry, no need to worry, and nothing to do but exist in this state of perfect, floating calm. The station is your sanctuary, and you are ready for a deep and restorative rest. The interior lighting of the station is carefully calibrated to support the natural production of melatonin as the crew approaches their sleep period. Unlike the harsh, blue-tinted lights of many terrestrial offices, the station's newer LED systems can transition into a soft, dim glow that mimics the warmth of a candle or a late afternoon sun. This light does not strain the eyes, instead, it allows the visual system to downshift, preparing the mind for a state of deep quietude. In this amber-hued environment, the metallic surfaces of the modules lose their clinical edge, taking on a soft, coppery radiance that feels protective and warm. It is a visual invitation to let go of the day's tasks and settle into the restorative silence of the orbital night. The behavior of sound in the station's air also has a unique quality due to the constant, controlled humidity. Because the moisture levels are so precisely maintained, the air has a specific density that carries sound in a very predictable way. There are no sudden echoes or sharp acoustic reflections. When an astronaut speaks, their voice sounds close and intimate, even in the larger modules. This acoustic intimacy fosters a sense of closeness among the crew, making the station feel like a small, shared sanctuary. It is an environment where loud noises are unnecessary, and where the most important communications are often delivered in a calm, steady tone that matches the rhythm of the station's life. On the exterior of the station, the many layers of the hull are separated by small air gaps and insulating materials. This Whipple shielding is designed to protect the modules from the impacts of tiny orbital debris. When a microscopic grain of dust hits the outer layer, it is vaporized, and the resulting cloud of gas is dissipated by the subsequent layers. This process is entirely silent to the inhabitants inside. The station is a fortress of quiet resilience, absorbing the energies of the cosmos without a sound. This engineering provides a deep, subconscious sense of security, knowing that you are encased in a vessel that has been designed to navigate the challenges of the void with total, unwavering stability. The scientific research conducted on liquid crystals in the station's laboratory reveals the hidden order of the physical world. These materials, which are used in everything from television screens to biological sensors, behave in space without the interference of sedimentation. They organize themselves into long, fluid chains that move with a slow, hypnotic rhythm. Scientists observe these changes through high-powered microscopes, watching as the molecules align themselves into perfect, shimmering patterns. It is a slow-motion study of harmony, where the internal logic of chemistry is allowed to express itself fully in the absence of weight. The lab remains a place of silent, visual poetry, where the mysteries of matter are revealed one molecule at a time. The process of air scrubbing is another silent miracle of the station's life support system. Using a combination of charcoal filters and molecular sieves, the system removes not only carbon dioxide but also the trace amounts of gases emitted by electronics and clothing. This ensures that the air always smells neutral and clean. There is a specific, quiet satisfaction in knowing that the very atmosphere you breathe is being constantly purified by a system that never tires. It is a mechanical version of the way forests on Earth clean the air, providing a fresh, invigorating environment that supports both physical health and mental clarity. The air is so clean it feels light, making every breath a small act of rejuvenation. In the cupola, the windows are fitted with heavy, motorized shutters that protect the glass when no one is observing the Earth. The sound of these shutters opening is a low, mechanical whir that signals a moment of wonder. As the shutters move aside, the vastness of the planet is revealed once again, a blue and white masterpiece that fills the field of vision. The Earth's horizon is not a flat line but a gentle, sweeping curve that reminds you of the planet's true nature as a traveler in space. Watching the sunlight catch the top of the atmosphere, the limb of the Earth, is a silent, breathtaking experience that happens every 90 minutes, a rhythmic reminder of the beauty and fragility of our home. The preparation for a meal in space is a tactile and sensory experience that emphasizes the slow pace of life. Because there is no gravity to hold a plate, food is often eaten directly from the pouch, which is held in place by a small magnet or a strip of Velcro. The act of eating becomes a series of deliberate, controlled movements. You learn to appreciate the texture of the food as it moves within the pouch, the way a thick sauce clings to a piece of chicken or the way a vegetable soup holds its heat. There is no clatter of forks or knives, just the soft, crinkling sound of the pouches and the quiet conversation of the crew. It is a mindful way of eating that turns every meal into a peaceful break from the day's activities. The station's external robotic arms, including the European robotic arm and the Japanese experiment module remote manipulator system, provide a network of mechanical assistance that covers the entire exterior. These arms are controlled from inside the station using joysticks and high-definition monitors. The movement of the arms is a study in precision and patience. They can move a multi-ton module or a tiny scientific experiment with the same level of care. From the windows, these arms look like elegant, white sculptures against the blackness of space, moving with a slow, mechanical grace that is entirely silent. They are the silent workers of the station, extending the reach of human hands into the vacuum. Inside the modules, the intermodule ventilation system ensures that the air is well mixed between the various sections of the station. This is done through a series of flexible ducts that run along the ceilings. The air flowing through these ducts creates a very faint, white noise that is similar to the sound of wind in distant trees. For many astronauts, this sound is deeply relaxing, providing a naturalistic backdrop to their life in the stars. It is a constant, steady sound that masks the more mechanical noises of the station, creating a sonic environment that feels organic and alive. The way a simple piece of string or a cable behaves in space is a quiet lesson in the laws of motion. If you nudge a hanging cable, it does not swing back and forth like a pendulum. Instead, it moves in a slow, undulating wave that eventually settles into a new, stationary position. It looks as if the cable is floating in a thick, invisible liquid. This lack of sudden, jerky movements contributes to the overall feeling of slowness within the station. Everything moves with a fluid, liquid grace, as if the entire station is submerged in a deep, silent ocean of air. The science of bone density research on the station involves the use of specialized scanners that measure the structure of the crew's bones with extreme precision. Because bones do not have to support weight in space, they begin to change their internal structure. This research is performed in the quiet of the medical module, a place of soft lights and focused observation. The data gathered here helps scientists understand how to treat osteoporosis on Earth, but in the context of the mission, it is another way the crew stays connected to their physical selves. It is a slow, methodical study of the human body's incredible ability to adapt to new environments. The exterior of the station is also home to a variety of exposure platforms, where materials are left out in the vacuum for months at a time to see how they react to the harsh environment. These samples, paints, polymers, and metals, sit quietly in the direct light of the sun and the deep cold of the shadow. They are the silent test pilots of the material world, gathering information that will make future spacecraft even safer and more durable. The station is a living laboratory that extends far beyond its pressurized walls, a silent collector of cosmic data that benefits all of humanity. As the station passes over the oceans, the reflection of the sun on the water, the sun glint, creates a bright, shimmering path that follows the station's movement. From orbit, this glint looks like molten silver poured over the deep blue of the sea. It is a brilliant, silent light that reveals the texture of the waves and the patterns of the wind on the water's surface. Watching the sun glint move across the Atlantic or the Pacific is a hypnotic experience, a visual record of the planet's vast, liquid energy. It is a peaceful, shimmering sight that reminds you of the deep, slow rhythms of the world below. In the quietest moments of the mission, when the work is done and the station is in its low activity mode, the experience of being in space becomes one of pure presence. There is no past, no future, only the steady hum of the fans and the infinite view out the window. You are a part of the universe in a way that is impossible to feel on Earth. You are floating in a state of perfect, weightless balance, protected by the best of human technology and the most fundamental laws of nature. Everything is calm, everything is slow, and you are ready for a deep and restorative sleep. The air on the station is constantly being monitored by a device called the Major Constituent Analyzer. This instrument silently samples the atmosphere every few seconds, checking the precise balance of nitrogen, oxygen, and carbon dioxide. It is an invisible guardian of the crew's health, operating in the background without any need for human intervention. The data it produces is a steady stream of numbers that represent the stability of the home. Knowing that the air is being guarded with such technological precision allows the mind to rest. There is no need to worry about the unseen, for the unseen is being measured and managed with the utmost care. This is the quiet promise of life in space, that the most vital elements of survival are maintained by the most reliable systems ever built. In the quiet modules of the station, the walls are often adorned with small, personal items that have been carefully selected by the crew. A photograph of a forest, a small drawing from a child, or a flag from a home country, these items are held in place by tiny strips of tape or Velcro. In the absence of gravity, they do not hang, they simply exist on the surface of the wall, becoming part of the station's geography. These items provide a soft, emotional texture to the metallic environment. They are silent reminders of the world below, providing a sense of continuity between the life of the astronaut and the life of the human family. They turn a laboratory into a home, a place where the heart can find rest as easily as the body. The behavior of a simple flame in a specialized combustion chamber is one of the most serene sights in science. In the stillness of microgravity, a flame does not flicker or dance. It takes the shape of a perfect, glowing blue sphere. It burns with a steady, quiet intensity, consuming fuel with a mathematical precision. There is no smoke rising, no crackle of wood, only the silent, radiant energy of the chemical reaction. Watching this sphere of light is like looking into the heart of a star. It is a slow and beautiful manifestation of the laws of thermodynamics, a reminder that even the most energetic processes can find a state of perfect, weightless balance. The exterior of the station is equipped with a network of external lights that illuminate the workspace during the 45 minutes of orbital night. These lights provide a cool, white glow that reflects off the white fabric of the modules and the silver insulation of the cables. From the window, this creates a scene that looks like a snow-covered castle drifting in a sea of black ink. The contrast between the brilliant white of the station and the absolute darkness of the void is stark and beautiful. There is no atmospheric haze to soften the light. It is sharp and clear, revealing every bolt and every handrail with cinematic clarity. It is a world of pure light and deep shadow, moving silently through the cosmos. Scientific research on protein crystals in the station's laboratory helps researchers understand the structure of complex biological molecules. On Earth, these crystals are often small and distorted by gravity, but in the quiet of space, they grow into large, perfect geometries. They are grown in small, transparent containers where the liquid is kept perfectly still. Over weeks, the atoms slowly find their places in the crystal lattice, building a structure of incredible symmetry. These crystals are silent masterpieces of biological engineering, providing the data needed to create new medicines and treatments. The process is a celebration of the quiet power of natural laws, operating without interference in the sanctuary of the station. The station's thermal control system uses large, white radiators to reject excess heat into the void. These radiators are coated in a specialized paint that is highly efficient at emitting infrared radiation. Even though they are being hit by the intense light of the sun, they remain cool to the touch because they are constantly radiating their heat away. This process is entirely silent, a constant exchange of energy that keeps the station's interior at a comfortable, unchanging temperature. It is a mechanical version of the way the Earth radiates its heat back into space at night, a rhythmic balancing of energy that ensures the survival of the inhabitants. Inside the modules, the sound of a colleague's breath can sometimes be heard in the quiet moments of the night. It is a soft, rhythmic sound that reinforces the sense of companionship. In the isolation of space, the presence of others is a profound comfort. The crew operates as a single, cohesive unit, their lives intertwined by the shared experience of the mission. They move with a quiet understanding of each other's needs, providing support and companionship without the need for many words. This social harmony is a key part of the station's peace, creating an environment where everyone feels safe, valued, and at home. The way a liquid moves through a capillary tube in the absence of gravity is a study in surface tension. Without the weight of the liquid to pull it down, the fluid can climb the walls of the tube with ease, drawn upward by the molecular attraction between the liquid and the surface. This process is slow and steady, a silent movement that is used in many of the station's life support and experimental systems. It is a beautiful example of how small-scale forces become dominant when gravity is removed. Watching the liquid rise in the tube is like watching a slow-motion magic trick, a demonstration of the universe's hidden mechanics operating in the stillness of the lab. The windows of the cupola are equipped with internal handrails that allow an astronaut to stabilize themselves while looking out at the Earth. This allows them to stay perfectly still for long periods, watching the world pass by. From this vantage point, you can see the thin, blue line of the atmosphere as it curves around the planet. It looks incredibly delicate, a fragile veil of gas that protects all life. Seeing the Earth from this perspective is a quiet and humbling experience. It fosters a sense of global unity and a deep appreciation for the beauty and resilience of our home. It is a view that remains etched in the mind long after the mission is over, a source of lifelong peace and reflection. The maintenance of the station's exercise equipment is a routine task that ensures the crew remains healthy during their long stay in orbit. The machines, such as the Advanced Resistive Exercise Device, are masterpieces of mechanical engineering, providing constant resistance without the need for heavy weights. They use vacuum cylinders and flywheels to simulate the pull of gravity. Using these machines is a rhythmic and meditative process, a daily commitment to the body's connection to the Earth. The sound of the machine's operation is a steady, mechanical pulse that blends with the background noise of the station, a sign of the mission's ongoing progress. The storage of the station's water supply is handled by large, flexible bags stored in the walls of the modules. These bags act as a radiation shield as well as a reservoir. The water is recycled through a complex system that purifies it to a level that is cleaner than most tap water on Earth. This closed-loop system is a testament to the sustainability of the mission. Every drop is precious, and every drop is reused. This sense of harmony with the environment is a quiet and constant presence on the station, a reminder that we are part of a larger cycle of life and energy that extends beyond the boundaries of our planet. As the station passes over the polar regions, the crew can often see the aurora australis or aurora borealis from above. These curtains of light appear as glowing, green ribbons that dance over the surface of the Earth. From orbit, you can see the depth and structure of the aurora, watching as it rises hundreds of miles into the thin upper reaches of the atmosphere. The movement is slow and undulating, a silent light show powered by the sun's energy interacting with the planet's magnetic field. It is one of the most serene and beautiful sights in the universe, a visual representation of the invisible forces that protect and sustain our world. The sensation of drifting while looking at the stars is a form of pure relaxation. When you are weightless, you have no sense of which way is up or down. You can rotate in any direction, watching the Milky Way pass by your window. The stars are bright and steady, their light unfiltered by the atmosphere. They look like diamonds scattered on a bed of black velvet. This view is a silent reminder of the vastness and the beauty of the cosmos. It invites the mind to wander, to contemplate the big questions of life and the universe in a state of perfect, floating calm. The station is a small, warm bubble of life in this infinite sea of stars, a sanctuary of peace and discovery. As you listen to these words, the station continues its journey, a silent and glowing dot in the night sky. You are part of this journey, a weightless passenger in a world of soft science and quiet discovery. The air is fresh, the lights are low, and the environment is perfectly secure. There is no need to hurry, no need to worry, and nothing to do but exist in this state of perfect, floating calm. The station is your sanctuary, and you are ready for a deep and restorative rest. Everything is slow, everything is safe, and everything is at rest. The station exists in a state of perpetual, quiet equilibrium, a mechanical and biological harmony that continues long after the lights have dimmed. Every system, from the slow rotation of the solar arrays to the silent recycling of the water, operates with a steady and predictable rhythm. This constancy is the foundation of the peace found here. In the weightless void, the traditional stresses of the world below are absent, replaced by a soft, drifting reality where every movement is graceful and every thought has the space to settle. The environment is one of absolute safety, a pressurized sanctuary that protects the life within it while allowing that life to witness the infinite beauty of the stars. As the International Space Station glides over the Terminator line, the moving boundary between day and night, the Earth below undergoes a soft transformation. The brilliant blues of the oceans fade into a deep, velvety indigo, and the golden webs of city lights begin to sparkle through the clouds. From this height, the world looks unified and still. There is no sound of the wind, no roar of the sea, only the visual evidence of a planet that is breathing and alive. To look down is to feel a profound sense of belonging to a larger story, one that is governed by the slow, majestic laws of celestial mechanics. This perspective is a gift of quiet clarity, a silent reassurance that everything is moving exactly as it should. Inside the modules, the atmosphere remains perfectly still. A floating object, perhaps a stray drop of water or a forgotten pen, remains suspended in the air, a small monument to the absence of weight. The air is cool and fresh, carrying the faint, clean scent of the high-tech systems that sustain it. As the crew rests in their soft cocoons, their bodies assume the neutral posture of total relaxation, free from the pull of gravity for the first time in their lives. The heart beats slowly, the breath is even and deep, and the mind is clear. It is a state of rest that is as deep and vast as the space outside the hull. The stars continue to shine with a steady, unblinking light, providing a crystalline backdrop to this journey. The Milky Way stretches across the blackness like a river of silver dust, silent and ancient. In this place, time loses its urgency. The 90-minute cycles of sunrise and sunset become a rhythmic pulse, a gentle metronome for a life lived in the stars. There is no rush to reach a destination, for the station is already exactly where it needs to be, drifting in the perfect balance between the earth and the void. It is a world of soft science and quiet wonder, a place where the mysteries of the universe are revealed in the stillness of the night. As you drift with the station, the details of the mission begin to merge into a single, cohesive feeling of tranquility. You are safe. You are weightless. You are at peace. The universe is a vast and orderly place, and you are a part of its quiet beauty. The station continues its endless, silent circle, a glowing sanctuary in the dark, carrying the dreams and the knowledge of humanity through the soft, velvety cosmos. Everything is slow. Everything is safe. Everything is at rest. The air around you is perfectly still and comfortably cool, much like the filtered atmosphere of the station. You are tucked safely into your own quiet corner of the world, where the heavy pull of the day has finally begun to lift. Just as an astronaut drifts into weightless sleep, you can feel the tension leaving your muscles, starting at your toes and moving slowly up through your body until you are completely relaxed. There are no more tasks to complete and no more facts to learn. The world outside your window is turning at its own natural pace, and you are exactly where you need to be. Like the steady, white noise of the station's fans, your breathing is rhythmic and calm, guiding you toward a deep and restorative rest. The stars are bright, the night is silent, and you are safe. Sleep well.